look at all the metal down on the bottom of the beaker. There's a lot of gold-plated stuff down there. I mean, there's some steel springs, but there's a lot of gold-plated stuff down there. So that's exactly what I want. I wanted to concentrate the gold. Well, hello scrappers, Mike here. Welcome back to my channel. What do we got going on today? Well, I've got yet another job for my friend Johnny in Finland. He has sent me a bag full of dip switches. He wants me to process them for him. Recover any gold they contain. I can see gold. Some of them have gold-plated legs. And I know a lot of these have gold on the internals. Maybe we'll get some silver out of them too. That'd be nice. So anyway, we're going to process these. First step's going to be to weigh them up and figure out what we got so we can calculate a yield here. Okay, the weight of the dip switches is 500 grams. Next, I'm going to crush them as finely as I can. How am I going to do that, you ask? Well, I'm going to use my favorite tool in the world, my mighty mill over here. And this thing is actually an ore crusher for gold ore, for sampling, but I use it for all kinds of stuff. It's driven by a angle grinder on the back here, and it's got some hardened shackle hammers inside that will pulverize anything I put in there, from hard rocks to this plastic stuff. And it works great. After we pulverize it, we're going to separate the plastic from the metal. I've got a method to do that I think you're going to find very interesting. It's my new favorite thing in the world. So we'll do that, and then we'll process the metals with acids and see what we get out of it. So let me get set up to get started, and we'll get to work on this and see what we can find in this bag of goodies. Okay, so how's this going to work? Well, I'm going to put these a handful at a time into the mighty mill and run it and let the hardened shackles in there beat the snot out of these dip switches. And then when I dump it out, there should be nothing but a powder left and some mangled metal. Look at the gold on that. I hope that's showing up. Huh. A lot of gold there. Okay. So, let's see what happens. That should be plenty of snot beating. Okay, I'm going to dump this out into a bucket. Oh yeah. I'll give you a look at what's in the bucket here. Oh yeah. Alright, I'll give you a look at that. So this is what we got left. Actually, some of this stuff looks like it could have the snot whacked out of it a little bit more. Like that, right there. A few other things. Maybe I need to run the mighty mill a little bit longer to make sure it completely pulverizes everything. Yeah, so let me try that. Okay, I pulled the stuff out of the bucket that looked like it needed more pulverizing and put it back in the mighty mill. Put in some more of these, maybe not quite as many this time. And let's do it again. With lots of agitation. Okay, let's see how this looks when I dump it out. There's some soft rubber parts in here that really aren't getting beat up all that well. They're just sort of bouncing around in there. But I think we've liberated the metal for the most part. There's some soft rubber here. The metal's kind of embedded in. If we don't have too much of that, we're probably okay. The hard plastic just shatters. Okay, that looks better. So, okay, I just need to run it longer and make sure everything gets thoroughly pulverized. So, let me run all these through, get them done, and then we'll take a look at what the result is afterwards and move on from there. All right, well, the Mighty Mill has done its usual wonderful job of chopping stuff up. So, got a bucket full of mostly plastic here. I see some steel springs in there. I see a lot of gold-plated stuff, but let's face it, this is mostly plastic and rubber. So I need to separate the plastic and rubber from the metals. And I will get set up to do that next and show you my new method of doing that. Okay, I've got all of Johnny's dip switches ground up. It's all in this bag right here. So, what's the next step? Well, wouldn't it be great if we just had an easy way to separate the plastic and the rubber from the metal in there? Because it's the metal we want, the rest of it's just in the way. So, how could we do that? Well, Jason over at MBMM, I'm sure a lot of you probably watch his channel too. He has a shaker table that would do the job really nicely. I don't have a shaker table, unfortunately, maybe someday. But I've been experimenting with another method to separate lightweight plastic debris from the heavy metal components I want. And so far in my experiments, it works pretty well. So let me show you what I've been doing. Here's the theory. Wouldn't it be great if we had a liquid that was heavier than most plastics, but lighter than metals? And if I just put this stuff in that liquid, the metal's going to sink to the bottom, the plastic's going to float on top, and I can just skim it off. Wouldn't that work great? Yeah. So where can we get such a liquid as that? Well, we can make it ourselves. Let me show you what you need. You need a damp rid refill, and there'll be links to where you can get that down in the video description down at the bottom, along with everything else I'm using here. And we need some water, and we need a mixing vessel, and that's all, okay? So how does this work? Well, damp rid is basically calcium chloride. It's very hygroscopic, which means it will pull moisture out of the air. So it will, eliminate damp in places. You put this in a container, put it in a damp area, it pulls the moisture out of the air. Okay. But calcium chloride dissolved in water makes the liquid denser than water alone. In fact, if we create a saturated solution of calcium chloride, we've got a liquid that's quite a bit denser than water and quite a bit denser than most plastics. So plastics will float on it. So what I'm going to do is I'm going to create a saturated solution or nearly saturated solution of damp rid. Basically, I'm going to dump this in this beaker and dissolve it in the minimum amount of water it takes to get it all into solution. And then we should have a very dense liquid. And then we can try floating off the plastic and sinking the metals. And then that's going to make life a lot easier. So let's give it a shot. Okay, so let's get this damp rid. These are just refills. Damp rid sells a little container that you can fill with this stuff and put it in a damp area. And when it stops absorbing moisture, you dump out the contents and use a refill to start it up again. Big lump there, which I'm going to try and break up. Otherwise, it's going to take a long time to dissolve. Ugh. Okay, that's not going to break up. Not easily. Anyway, we're going to dissolve this stuff in the minimum amount of water it takes. And I got to warn you, this gets pretty hot as it's dissolving. Oh yeah, getting warm already. I'm just going to keep adding water in small increments until I get all of the solids dissolved. Then we should have a pretty darn dense liquid. A little bit more water. And it will clarify too over time. I think this white color is from just small particles of calcium chloride. The liquid becomes clear once everything's dissolved. So I'll keep stirring and adding small amounts of water until I get this all dissolved. Oh yeah, very hot, very hot. Not quite as bad as dissolving, say, lye in water, but it does get hot. So be prepared for that fact. Use a container that can handle a little bit of heat when you're making this stuff up. All right, I'll be back when I've got this all in solution and we're ready to move forward with separating that stuff. All right, I've got the calcium chloride all dissolved. Ooh, this is quite hot. It's still kind of milky, but I think that's from the anti-caking agents and perfumes and crap they put in there. If I was to let this stand for a while, the stuff would settle out and become clear. Not going to bother letting it stand for a while. We're going to use it right away. But I do want to answer a few questions that are probably going through some of your minds out there. Number one is, how dangerous is this stuff? The answer is not very. I wouldn't drink it, and I wouldn't pour it on your lawn. But on the whole, calcium chloride is not a terribly dangerous chemical. If you live in a cold climate, it's what they're spraying on your roads to keep it from freezing and icing over in the wintertime, okay? So, yeah, that's your municipality's spreading a lot of it around the environment. It may kill the grass at the side of the road. That's about it. You can dump this down the drain. I mean, don't dissolve nasty stuff in it, then dump it down the drain. But, you know, as it is, you can dump it down the drain. Your municipal water system should be able to handle it. I wouldn't put too many packs of it down if you have a septic system, because you might poison your septic system with too much salt, because basically it's a salt. So there's that. But on the whole, it's pretty harmless. I'm going to make this work even better by adding some Finish by Jet Dry to it. And what this does is it breaks down the surface tension of the liquid. So stuff that's dense is going to have less of an ability to float in here. It's going to want to sink. So I think we're ready to go. So let's see how this works on dip switch debris. I've done this with other stuff on a small scale, and it's worked pretty darn well. Haven't tried it with this stuff, so we'll see. Now, I can fine-tune the density of this liquid. If I find that I've got valuable stuff floating, I can just add more water to it to dilute it until the valuable stuff sinks. So, I mean, here's a piece of rubber and plastic with some gold embedded in it. That might float just because there's so much rubber and plastic there. I'm going to just set that aside. But I'm going to take a handful of this stuff and put it in here. Oh, look at that. That's working pretty darn good. A couple handfuls. Stir it up. All right. Can you see what's going on there? Most of the plastic is floating. I see one or two little pieces of metal there, but as I stir it, they've sunk out of sight. So the plastic is floating. The heavy stuff's down on the bottom of the beaker. So now I should just be able to skim the plastic and rubber off the surface. Just like that. And that could go straight in my recycling. Drain some liquid off of it. All right, so that can go straight in my recycling. How neat is that? No shaker table needed. Eat your heart out, Jason. Although I really, honestly, would love to have one of your shaker tables, buddy. They are the bomb. I'll put a couple more handfuls in, stir it around, and do it again. You want to get everything good and wet. And then once it's all thoroughly wet, the density differences will take care of what floats and what sinks. Now we're not going to get rid of all the plastic and rubber this way, and we might actually pull out a little bit of gold-plated metal. There's a piece right there that's floating for some reason. See if I can get it to sink. Maybe it's attached to a bigger piece of plastic. I don't see it now. I think it sank. But on the whole, I think we're going to get a pretty good separation between the heavier metal down here and the lighter plastic. Again, we'll just skim it right off. And this works on a bigger scale too. You can scale this up as much as you want. So this is one way to separate, plastics from metals without going to the extreme of incineration. You can reuse this liquid over and over again. It's not a one-time thing. You make it once, but you can use it over and over again. When I'm done here, I'm going to put it in a container and put a lid on it and just set it aside for next time. I may filter it just to get all the debris out of it first, but yeah, you can use it over and over again. Not a one-time thing. Anyway, I'm going to keep this up until I get all of this debris from the dip switches through here and separated. Then I'll pour off the liquid and we'll see what we've got captured down on the bottom. And a lot of this stuff isn't wetting very well right now, so I'm going to put in a little bit more of the Finish by Jet Dry. Yeah, that's better. Now it's wetting. If it doesn't wet, it's not going to separate well. Got to wet. Plastic's pretty hydrophobic, so it doesn't wet. Anyway, like I said, I'm going to keep this up until I get all this stuff run through. Might want to wait a few seconds before you start skimming. It's a fairly dense liquid. Give the heavies time to sink. Then skim off the stuff on the top. And I'll be back when I've got it all through. All right, so I have run all of the dip switch material through our dense liquid here and skimmed off as much of the plastic as I could. As you can see, there's still a lot of plastic down here in the bottom of the beaker, but I think some of it's either very dense plastic or some of it has bits of metal embedded in it, making it heavy. And we don't want to get rid of that metal. I see a lot of metal in here. Oh yeah, as I stir it around, there's a lot of metal. So, yeah. And then if I look at the bottom of the beaker, oh yeah, there is a lot of gold-plated metal on the bottom of that beaker. So good. We've accomplished what I set out to do. We've concentrated all the heavy stuff, including the gold-plated stuff, into a much smaller volume. We've gotten rid of maybe 3/4 of the useless plastic here without having to burn the stuff and piss off my neighbors with a lot of black putrid smoke and hurt the environment. So that's good. So I've poured the liquid off, and I will filter this later and put it in a closed container so I can reuse it again. I can reuse it ad infinitum. There's really no limit to how many times I can use it. Now, one thing I do want to do, though, is I want to give this stuff some rinses before we move on to the next step. So I'm going to put some water in here and just give this stuff probably 3-4 rinses before we move on to the next stage. We're going to wash some of this stuff down off the sides of the beaker too. Because the next stage is going to be nitric acid extraction. I want to get rid of the copper in here. I want to get rid of the iron in here. Any other base metals. I just want to get rid of them, okay? Before we go on to aqua regia to dissolve the gold. So right now there's a lot of calcium chloride in here, and I want to get rid of that before we go to the nitric acid extractions, because if I just put nitric acid on it right now, we're going to make poor man's aqua regia, and I don't want to do that. I want to get rid of the chlorides best I can before we do that, and then just use the nitric acid to extract the other metals, and then once this stuff's cleaned up, we'll go to aqua regia and get some reasonably clean gold out of it, I hope. I mean, you could go straight to poor man's aqua regia if you want. You're just going to have some nasty, nasty, dirty aqua regia in the end. And it's probably going to be an ugly colloidal gold drop. So, you know, it's up to you. I prefer to get rid of it first and then go to nitric acid. So I'm going to give this, like I said, maybe 3-4 rinses. And then we'll go into the fume hood and put some nitric acid on it and see what we can extract from it. Okay, I just finished with rinsing the chloride out of this stuff, and as I'm pouring it off, look at all the metal down on the bottom of the beaker. There's a lot of gold-plated stuff down there. I mean, there's some steel springs, but there's a lot of gold-plated stuff down there. So that's exactly what I want. I wanted to concentrate the gold in the bottom of the beaker. So we've done that. Like I said, reduce the volume probably by 3/4. Excellent. My cutting plan is working just fine. Okay, let me get this in the fume hood, and we will start giving this some nitric acid extractions. All right, got stuff in the fume hood. We get some distilled water on it. Just want to cover it all up. And now we're going to start the fume hood up. And we're going to do some nitric acid. You can do poor man's nitric if you want. Put some sulfuric acid in there and the nitrate salt. You don't have to waste money on the expensive stuff. I just happen to have a lot of nitric acid on hand at the moment, so we're going to go with that. Wow. Holy moly, look at that reaction. Well, yeah, there's a lot of iron in there. There's a lot of copper in there. So, yeah, we got quite the reaction going on. I don't even have any heat on this. This is all cold. So, yeah, stone cold. So I will probably put a little bit of heat to it here, not too much, just a bit to warm things up, keep things going. And that reaction stops. I'll put a little more nitric acid on it, and I'll keep that up until I don't really get any more reaction out of this stuff. Then I'll figure all of the base metals are chewed up by the nitric acid, and we can move on to the next step. So this is probably going to take a few hours, though. I mean, look at it. The liquid's already turning a deep blue. It's been seconds. Seconds. I love nitric acid extractions. They work that well and that quick. But I'm going to let this go for at least a few hours, like I said, just to make sure I get as much of the base metal out of there as I can. And when I finally do the gold extraction with aqua regia, we'll get reasonably clean gold. Much cleaner than I would get going straight to aqua regia right now. Okay, so we're just going to let this cook and be back when something interesting happens. Alright, it's been a while. The reaction has died down to nothing really, so I think it's time to put a little bit more nitric acid on here and see if the reaction revives. I'm going to put a little bit. I'd say that's an affirmative right there. Yeah, I'd say we got some more reaction going on. So, okay, I'll just keep this up, putting little dribs and drabs of nitric acid in there until I don't see any more reaction. And then I'll know all of that base metal is chewed up. Oh yeah, we got more got more brown orange fumes forming. So yeah, definitely something going on. All right, so this might just take a while, but it's okay. I'm not in a big hurry. We'll get there eventually. All right, I think we're done. My last addition of nitric acid didn't produce too much of a reaction here. Not a lot of bubbling, not a lot of orange-brown fumes. So I think we're done. Now, I want to decant this liquid off and rinse what's left in the bottom a couple of times to get this blue stuff off of it, get out of as much of this base metal salts as I can. But there's one thing I want to do first. I want to test this for the presence of silver. See if we got silver in there. Then I'll know what to do with the liquid I take off, whether I save it or pitch it. So let's test it and see. Alright, so I've got a little bit of tap water here with a splash of uriatic acid in it. We get some of this liquid. Oh yeah, we got a nice cloud forming. I was thinking there might be some silver there. Yeah. You know, opaque that got. Okay, so we've got some silver. It's not a huge amount, just a little bit. But I'm going to save that liquid because I know I've got some other stuff of Johnny's to process that's going to have small amounts of silver in it too. So I'll just combine all the small amounts of silver I get until I've got something worth trying to recover, because there's not enough here to bother trying to recover. But I think we can build it up over time. So I will decant this off into a container that I can save that liquid in. And then, after I rinse this a few times, get as much of the base metals out of it as I can, we'll be ready to hit this stuff with Aqua Regia. So, let me get that done. We'll be back. We'll go to Aqua Regia, see how much gold we can get out of this stuff. Well, here's a bit of a complication to me just pouring off this blue liquid. I don't know if you can see it. There's a lot of little gold balls floating on the surface. They must be hollow for them to float like that. So I don't want to get rid of them. They're gold. So I got to figure out a way to filter them off. Yeah. And then return the filter back to the beaker when I go with Aqua Regia. So okay, let me figure out a way to filter these off. All right, here we go. I will just pour this liquid off through a filter. We'll catch all those little gold balls. And return the filter to this beaker when I'm ready for Aqua Regia. There we go. It's going to take a while. I can see the filters plugging up already. Oh well. You don't have to watch it. Be back when we're ready for Aqua Regia. Well, alright, this looks like probably a good stopping point because the weather's coming in fast. I can hear thunder in the background. The forecast is pretty ugly. So I'm going to wrap up what I'm doing here and get in the house. And we'll pick up here when the weather permits. The next few days are supposed to be pretty bad. But as soon as I can get back out here, even if it's in waders, I'll come back out here and we'll pick up where we left off with these dip switches. So if you guys found this video at all interesting, educational, informative, inspirational, whatever, give it a like, give it a thumbs up. I'd appreciate it, and I'll see you in the next video. Subscribe to see the next part. See you then. Bye.